Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And very good morning. We begin with Surah Fatiha. Auzubillahi minash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Alhamdulillahi rabbil alamin. Ar-rahmanir-rahim. Maliki yawmiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. Okay, for manual attendance, maybe you can write your metric number and course code, and then just leave in the chat box. Later, at the end of this lecture, I will do the attendance. Okay, so we begin. Bismillahirrahmanirrahim. So this is our lecture 3. Okay. The voice is loud and clear?
Yes, can hear.
Thank you. Photography, part 2. Okay, so this is our recap. In our previous lecture, we talked about public key cryptography. Okay, and then in our public key cryptography, we assume that each participating bodies, they have two keys, public key and private key. For instance, Alice have public key and Alice has corresponding private key. For example, Alice has her ID, email address, and the private key. Okay, so we have plain text. We encrypt this plain text using receiver's public key. Okay, so and then we get the ciphertext. We send this on air. Okay, and then we get the ciphertext. The receiver decrypt the ciphertext using receiver's private key, just like if you people send me an email, so you have to use my receiver's email address. And once I receive email, I will use my private key to decrypt the data. Okay. So it seems secure, but there is one possible attack, that is impersonation attack. For instance, if I receive email from any of my friends, my students, and then at the end of the day, the students claim that, no, sir, I haven't sent that email. Okay, so which means that somebody impersonate my student. Okay, so there is no point in this public key cryptography. There is no point to verify that the sender is like Gmail. For instance, you people receive email from me, and then Adnan Shahid Khan at Gmail something. So anybody can design that email, right? So which means that there's in this public key cryptography, there's no point, there's no way to validate the sender is a legitimate user. Okay, so the solution for this problem is public key infrastructure, also known as PKI. Okay, this one is 2022, last year. So around 11,000 something, and still a lot of research going on in PKI. Okay, so this one is a lot of algorithm or a lot of security issues. They are trying to resolve those security matters using PKI. Okay, how PKI work? Again, we have public key and private key. We assume that. Okay, so for that, for Alice and Bob, this is about PKI. Okay. In PKI, we have registration authority, we have certificate authority. Okay, so before we submit key to RA, okay, so we must either, it's up to us to generate two keys. Okay, so like once you go to Unimas, first time you enter Unimas, and then you have to register yourself. Okay, so they will give you some unique ID. Okay, at siswa.unimas.my. Okay, so for that, for students, we cannot allow them to bring your own ID because the chances for unavailability of that ID is high. So we have our own sequential number. So that is your metric number. Okay, so that is one key. So this RA generate keys on behalf of the user. But for lecturers, this one is done by university or by ourselves. Once I joined Unimas, they advised me, okay, give me 7 digits. So I say, okay, SK Adnan. That is I choose by myself. And so, but however, in any organization, in any industry, if you go to industry, they will ask you, give me the username and then give me the, no need, normally they will choose your IC as a password. Okay, so you see those keys are still not, before you join Unimus, those keys, there's no linkages among us themselves. So once you submit the keys, so those keys, so you have to submit those 2 keys plus all your credentials, your home address, your parents' name, your IC number, your IC, your education documents, all those critical credentials that really can tell you about your identity. So you have to submit this document to registration authority. Then Unimus, as a registration authority, they will verify your documents. Okay, so once they verify, then they submit this document to certificate authority, CA. CA binds these 2 keys and create digital certificates or digital signature. Okay, so this one is the job of CA, third party. Okay, so this one is a literature review. Okay, technically how this works, because PKI ensure CIA, okay, even availability. So how PKI ensure? For example, we have plain text. Okay, we encrypt the plain text using Bob public key. Okay, we get the ciphertext. Okay, this one is similar as a public key cryptography. But here, once we get the certificate ciphertext, we have to hash the ciphertext. Okay, so once we hash the ciphertext, so this one and these 2. Okay, now this one we have to send this together, the ciphertext and the hash of ciphertext. Okay, and then we have to encrypt these 2 guys using Alice private key. Okay, so this one is E is encryption, these 2 guys using private key of Alice. So this one is, we call this digital signature. Okay, DS. Okay, so this we send through insecure channel. Okay, and then we get DS here. Okay, so you see from here how decrypt. We receive this exactly same message. Encrypt CT ciphertext per hash of ciphertext. Okay, so Bob will use Alice public is widely available. As the name indicates, a public key. Okay, so anybody can apply, any attacker can apply here. So attacker or Bob can get CT and hash of CT. Okay, so this one we get. See, still this is secure. No, there's no point. If attackers can see or the legitimate user can see, there's no issue. Anybody can see. Okay, so the point for this one is to ensure that you see, if I apply Alice public key here, which means that this message came from Alice. Okay, if I apply this encrypt by Alice private key and I apply Adnan public key here, it will not work, which means the chances for impersonation attack is no, right? It's non-repudiation. Okay. If I receive any message from this one, I know the message came from Alice. So there's no point of impersonation is done. Now we have ciphertext and we have hash of ciphertext. Okay, so we take this one. Okay, this black color. We hash this black color. Okay, this one. Once we hash this one, we get some value. We have to match this value and this value. If both values are same, which means during this value, there's no change here. Okay, so we get the ciphertext. Later, in our next slide, we'll see what is the hash. Okay, so once we hash, we get the ciphertext. So now the ciphertext, Bob use his own private key to decrypt and get the plain text. Okay, so this is how PKI work. Okay, so this one is, you can repeat this video and then try to learn it. Okay, for registration authority, during your initial registration process at Unimas, the same thing what I explained just now. You need to fill in the form, fill all credentials. For instance, full name, parents name, home address, IC number, username, usually admin do on behalf of you for students. Okay, all important credential that shows your complete identity. Okay, so this we all together we send this to Unimas. Okay, for registration. So this one is key. The first process is a key generation. This one is username and IC. Normally IC we take as a private key, and this one is done by admin officer. Right? So once we key generate, we do registration. Right? Key generation, key creation. Okay. Then we have verification. Okay. This by RA verify, and then verify by CA, and then key creation. So key registration, then key creation, then later on we have to, just like my Unimas, my contract normally expire after 2 or 3 years. So once my contract expire, once my contract renew, they have to renew my IDA. If I just left Unimas, they have to revoke my keys. So this is the life cycle of the keys under RA. Okay, so this one is I think that's the same slides. The same slide. Hash. Basically, see Adnan. If we hash using any algorithm, if you hash Adnan, this we get 26BA. If you hash Adnan, a small change here, we get different value, entirely different value. Okay. If you hash Adnan 10 times, we get this value. If we hash anything, any amendments here, say all the values change here. Same goes here. If we hash ciphertext, at any point, example, attacker take these values. Now this value is with attacker try to modify this value or modify this value. We assume that attacker modify this value. Okay, they add its own ciphertext here. Okay, so you see at this point, then okay, this one is 1 1 1. Okay, this one is. So if I hash CT, this CT, we get 1 1 1. Okay, at this point, if we hash CT, this is 1 1 1. Okay, so this is 1 1 1. If suppose attacker change this one, sorry, this point, we hash this point. So this one is not same as this one. So the value can be 2 2 and 2. See, this one does not match. So the Bob will or the server will silently discard the message. Okay, this is how this works. Okay. Okay, what is the PKI made of? PKI made of CA, digital certificate, application that are written to use PKI, like our browser. Okay, and then policies and procedures. Okay, so these are PKI made of. Okay, issuance, management, and revocation of certificates. This one is literature. When request for certificate is made to a CA, a key pair must be created and signed by. This one is the same. Okay, CA must verify. Okay, same. Okay, wait. Okay, it's the same. CA signed the public key. Okay, this is the same. Certificates are generally stored on the in our Explorer. Okay, normally, many reasons to might be revoked, just like somebody have stolen my key, or sometime Adnan left our organization. So this one is something literature reviewer. Okay, this is our lecture 2. So in our previous lecture, we discussed PKI, public key cryptography, and what are the problem with public key cryptography, that is the impersonation. Okay, and how to mitigate impersonation and how to ensure CIA using PKI. So this one we have done all those. This one. we ensure confidentiality, this part, and this one is for encryption. Okay, this one is integrity. Okay, nobody can change the data. If anything modification, we can claim that the data is modified. Okay, so this one is C, this one is integrity, and this point is impersonation and non-repetition. At the end of the day, if I receive message from this digital signature, for sure this message came from Alice. At the end of the day, she cannot deny that the message doesn't came from her. Just like if I'm using SKS, not Gmail. If you receive any email from me using SKS at Unimas, which means that this is PKI. So or I receive any email from at siswa.unimas.pi, which means that came from my students. So at the end of the day, my students cannot deny that, oh, sir, I haven't sent that message. Okay, so this one is this lecture we discuss public key cryptography, problem with public key cryptography, that is impersonation, and then we discuss PKI and how PKI ensures CIA and non-repetition. Okay, so we go to our lecture 4 using, and this one is utilizing cryptography in our identification and authentication procedure. Okay, for instance, the same messages previously it's like that. Okay, normally the messages are like this. Okay, straight. Okay, like this. But here, if you see, I just tried to make the same messages in our previous lecture. Alice need to use CME Bank here. So she will write www.cme.my, enter the request, and that is authentication request, goes to insecure channel and goes to server. Example, this is server authentication request. Bob will respond, authentication response, challenge username and password. Okay, this Alice receive authentication response message. Then Alice enter username and password. Okay, and then enter username password, so it's authenticated. Okay, so username and password can be any identification what user have or even biometric. Yeah? So this one is beginning, is the ice breaking session for identification authentication mechanism. This is literature. Okay, let me read for you. Authentication. What is authentication? In cybersecurity, refers to the process of verifying the identity of an entity, such as user, device, or system, to ensure that it is legitimate and authorized to access the specific resource or perform a specific action. I think this one is now no more critical terms, since we are using a lot of mobile devices and lot of application. Everything is app based. So once we use the app, we have to go for authentication. So for authentication, they require some identity. Authentication involve a user credential, which are unique piece of information that are associated with a particular entity and used for identity. Okay, common types of credential include username and password. Okay, smart cards, bioinformation. Okay, just like nowadays, CME Bank, you can use a thumbprint. Okay, security tokens. So these are authentication involves. May require the entity to provide one of more credentials. There are several methods or factors used in authentication, known as authentication factors. Okay, they are divided into 3. Okay, one is something you know, something you have, and something you are. Okay, that is very important from your examination perspective. Okay, something you know, this factor involves knowledge-based credential like password. Something you know. You know your password, you know your PIN number. Okay. And then something you have, maybe something smart card, okay, mobile devices, token, okay. And then something you are, that is your biometric information. So these are the factors. Factors are categorized into 3 main types. Multi-factor authentication is a common practice in cybersecurity where 2 or more of these factors are combined. Like for single factor, this one, if this one and this two combined is a double factor or dual factor, 1, 2, and 3 is combined, it's a multi-factor. Okay. Authorization, as the name indicates, once you apply for authentication, the server will authorize you or grant access. So authorization in cybersecurity refers to the process of granting or denying access to specific resources or action based on our authentication user permission. Once a user or entity has been successfully authenticated, authorization determines what action or resources they are allowed to access based on their privileges. Authorization typically involves the use of access control mechanisms that are implemented based on predefined policies. Okay, these rules determine what actions or resources a user is allowed to perform. So this one is straightforward. Identification is referred to the process of uniquely identifying an entity, such as user, device, system within a system or network. It involves associating a unique identity or label with an entity to establish its presence and differentiate it from other entities. Through the use of unique identifier or credential that are associated, just like your email address, username, email addresses, device IDs, IP address, MAC addresses. So this one is uniquely, so that is identification. Authentication protocol types, we have unilateral authentication. Okay, unilateral, which means if we have client and server, so only one party is authenticated. Usually server authenticates the client. Okay, so unilateral. Mutual authentication, we have, say example, we have client and we have server. So in unilateral, they send the request, server will ask for authentication information. They will send the authentication information. So later on, server will authenticate this guy, unilateral authentication. Later on, there's a lot of problems with this, so we go for mutual authentication. So this go for server authenticate this one and client authenticate server. Okay, one-factor authentication. This is something a user know, that is one-factor authentication. Two-factor, in addition to the something user know, something user has, two-factor. Multi-factor, 3, 1, 2, and biometric, 3. So this is how we can differentiate. Okay, the same thing, the same slide repeating. Okay, for protocol, we know that this, I think this one is, you can go back and read how protocol work. Protocol is a set of rules of exchanging messages between two or more devices. Okay, as number of rounds, like for instance, if you need to register my WhatsApp group, what is the protocol? You have to register with your course. Okay, your course, then you have to register with eLib, then you will find, and I have to register, I will ask CAM to create a page for my course. CAM will create a page for my course, and then I will create, you see a lot of steps. I will create WhatsApp group, get the link, and then I will post the link in eLib, and then you people will get the link and then click and then join. You see, this is it's a protocol. Okay, so how unilateral protocol work? This is normally every day, but nowadays not this one is working. You see, if we click till 2010, okay, this one is still, I remember once I was in doing my master's at UTM Johor. So this CIMB, they use the same thing. You have client request for authentication. Server will ask, okay, enter your challenge. What is your name and password? So you enter your username and password, get authenticated. You see, this one is server authenticate client, but there's, if something is here, if this is not legitimate website or this is impersonation or phishing, then the problem. So this client can use, nowadays this happen, this password guessing. We use phishing website. Okay, so the phishing website is like this. Okay, so they will get the information, and then later on they act as a Alice and then communicate with server. So you don't know either server is legitimate or not. Chances for phishing or impersonation is high and can cause man-in-the-middle attack. Okay, like if this get all this information and then later on this become like this, and this one is Alice. So this one is say is a man-in-the-middle attack. Okay. Same goes for client. If it's spoofing and all, sometime if we don't authenticate client, then if spoofing means still phishing can occur here. Then to remove this problem, we go for mutual authentication. We server authenticate client, client authenticate server. Okay, how this happen? During registration process, okay, we have to enter a secure word here. Okay, during registration, we say, okay, the secure word is Adna and Adnan, for example. Okay, this is a secure word, which means this word is because I register myself with this server. Whatsoever, if I cannot get this word, which means this is not that actual server. So I go for request, click the link, they will go for the challenge. I enter the username. Okay, so I enter the username. Okay, then they will give us the challenge to enter the password, plus this enter username is I'm giving you the challenge to show me my secure word. So at this point, just like you go for CIB Bank RHP, the same thing. Yeah? So this, if they clearly show my secure word, then I can enter the password. So this one is mutual authentication. Okay. Secure word was only saved during registration. Okay. Process at servers. Okay. So you see this one is, it look like it's for mutual authentication. It's okay. But if something goes in password guessing, password guessing is nowadays very common and easy to do password guessing. Okay, so now we know the problem here. The problem is the password guessing. If someone get the password, that problem. Okay, so two-way phishing or impersonation is high. Okay, this is analysis. First, I can try to do cryptanalysis and do spoofing. Okay, this one later we'll see. And then offline password guessing. Okay, once the password guessed, create phishing client to server and get hold of the communication. So still MITM can happen. If just like password guessing, if this one is the link, okay, this one is the phishing website. Okay, this is again, suppose example, this is phishing website. They can communicate here and get the password. They communicate later on. They enter the username. Okay. And then even the problem with our banking system is still in Malaysia. You see, if you enter wrong username, you get the secure word. So we can collect the whole day. We can spend time. We can have the list of username and the secure word. Okay. And then later on we can do password guessing. Okay. So password guessing is very simple mechanism nowadays. So you see this is a problem with visual authentication. Okay, so we go for two-factor authentication. This one is user knows. So we enter our, okay, verify, okay. This one is the secure word. Then we enter the password. This one is authenticated. This one is okay, normal procedure as previously. So now for just like RHP, if you do any payment above 5,000, 2,000, you have to set that. So then they will send you OTP. Okay, so that is once user have. If password guessing happen, doesn't matter. Okay, if someone know my password is 123, example. But still, if you need to do any transaction, they have to go for two-factor authentication. Another factor here. Okay, that is for like OTP. So you get the OTP on your devices. Okay, so this one is on the top of single factor, it look like secure. Okay, and then we have another multi-factor. Okay, besides that, most of the organization they go for multi-layer authentication mechanism, just like on your airport. Okay, so they enter your index finger. Okay, so press, so that is the user has it. So this one is, we call this multi-factor authentication. It comes at the expense of high complexity. Yeah? You see, the messages are becoming bigger and bigger, but it's a secure. Okay, so you see, starting from symmetric symmetric key, problem is scalability, and then we go for public key cryptography. The problem is impersonation. Then we go for PKI. Okay, then PKI can ensure. Then we have multi authentication mechanism where we utilize PKI. Okay, normally, yeah. So you see, this one is all PKI based. We can use PKI here. Okay, so in authentication we have single factor unilateral, then multi-factor authentication, then two-factor multi-factor authentication. Okay, now we go for password guessing. Authentications over network key phenomena. The main thing is secure password. Okay, there's several steps the attacker, and this must be 13 steps attacker might try. No password, single, these are all steps attacker can try. And then sorry, the last one is system search, sniffing and spoofing. So this one is we'll discuss here. Okay, for example, in our previous system, the passwords are safe as plain text. Okay, but protecting by access control, like the password is there, but if I register myself with Windows, okay, so I enter my username and password with a window, the password is there. Okay, but it's access control. Okay, however, if memory dump and searching for password table, we can get that. Get password from the system back. So this one is how to get the password. Backup often include no file protection. Okay, so this is how we can get the passwords previously. Get password file by attacking this. So this one is previously we can get the password. So later on, passwords were encrypted using any encryption algorithm. Okay, so entire table or specific column are encrypted. Okay, so how to get the password? Penetrate memory or finding the key become possible. So this one is we can get. So later on we have a lot of attack on this. So now we move to the third step. We hash the value. Okay, normally how Windows save the password. Okay, during our registration process, if my password is Adnan, example, so Windows just do the hash. Okay, and then save. Okay, hash and save like this. Then enter password. Windows will hash the password, save in the database. Okay. So the chances to get same password is just like you and me. I have 250 students. So maybe the password is 1, 2, 3, as simple as means anybody can. So maybe out of 250, this one research that maybe 2 to 3% there is a chances for have the same password. Okay. So now they use the salt value, any value. This is my password Adnan, and then plus 1. Okay, so see this whole hash value change. We have learned in hash, the whole hash value change. So this one is another come. So my student that we have the same password. So 1, 2, 3, we have salt value. Okay, we increment this salt value. Okay, so another password 1, 2, 3, but this is with 2. So see, this one is how we can use with the chances for same password is now resolved. Okay, now this one is how to register and how Windows save the password. Okay, so in communication, how the attackers try to get those passwords. So we have sniffing, spoofing, impersonation. Okay, attackers get the password list including all other credentials. Okay, click the link. Okay, so once you receive any email or anything, there's a link. You click the link. Attacker may install malware. Okay, so any keylogger, anything. Yeah? So once there is malware, later do the system search, get the hash passwords. Since it's we cannot get the even if you go to admin office and then ask for to retrieve the password, there's no way to retrieve the password. Okay, once it's hash, Windows only save the hash value. Okay, so there's no way to get the password and nobody knows. Yeah? So attacker get the hash values. Okay, for example, these are the hash values. Attacker get a lot of, maybe billions of 2 GB, 10 GB data of hash values. Yeah? Okay, so now attacker write a script, transform word by word in sequential the list of password and the hash values. Okay, and then see either any values coincide in the available hash group. We call this dictionary attack or brute force attack. Okay? For example, these are the list of password. Okay, we use dictionary attack, and these are the hash values. Okay. Sorry. Okay, so if say we try, attacker take this word, attacker hash, okay, this one, and match here. Not found, this is not the password. Take second one, hash this one, found from here. Cannot, no worries. So suddenly attacker go to maybe 3 hours, attacker go here, and then attacker see, oh, this S7 is the hash value for this, which means this is our password. Okay, so this is how the attacker try to get the password. And so this PCs, normally this PCs, our PCs, office PCs, normally take 3 months to do this scripting. And we can get a lot of hash values online. We can get a list of passwords. Google can help you to get the list of passwords. So we are the human, so normally we choose the same passwords. And to get the passwords, we have sniffing. The attacker maybe spend 6 months with us. They go to shopping, they try to know our family members, everything. Suddenly they know ample information, they strike the attack. And normally at the end of the day, scamming, you see in Malaysia, scamming is very easy. Okay, so this one is how password guessing. Okay, so we have assumed this how this attack work. We have victim. Okay, this is basically it's a legitimate user, but it become a victim. This is a blue color. It's a server. It's an original link. Okay, so at this point, it's an offline links spoofing, offline password guessing. Okay, this assume that we have done that. Now we have list of passwords. Okay, so list of passwords. So here the attacker take all those things. Okay, and then try, say attackers have maybe for 6 months he collect 20 different passwords. Okay, so attacker, so they will send the request to server. Server will go for challenge. Attacker use guess passwords. Okay, password. If failed, then another chance. Okay, if failed, another password. So we have 20 different passwords. So if you see, if failed, another, failed, another, failed, it's become a typical replay attack. Every time server have to calculate, server have to dig into their system and do computation. So system may exhaust. Several replay attack, usually 20 times or similar, sometimes it's only 3 times. The server will exhaust doing unnecessary computational, thus will deny the legitimate user for the service request. So once this denied, it become a denial of service attack, typical denial of service attack. Just like for Facebook, we enter the wrong password sometime, or sometime in your mobile devices, if your kids or your friends do 5 or 10 times, they will block for 30 seconds. It's a denial of service attack. Okay, So you see the impersonation attack, replay attack. So initially we go for impersonation attack. Okay. Then we have replay attack. If replay attack is successful, okay, it's a typical man-in-the-middle attack. If replay attack is not successful, it's a denial of service attack. Okay, so these slides we talk about some communication attack. If password guessing happen, so we have how MITM can occur. Okay. Okay, so example of our authentication process and vulnerabilities. Example, if Alice send their ID encrypted by Bob public key, okay. So attacker can take this key as it is, okay, because this one is a public key. Look like we just, okay, impersonation act as we have discussed. Attacker modify here, okay, or attacker do something. This one is a true D example. This A is Alice, this T is true D. Okay, so true D means attacker. So true D, they change this and then set. The typical modification and impersonation can happen. So what to do to solve this? We can have, because this is a modification attack, so we can use hash to reduce this. We have ID, we take the hash of ID. Okay, if any change here, we can discard the message. So encrypt, for impersonation, we have to encrypt using private key in our first lecture, today's lecture. So PKI. So this and then, so this we use PKI to resolve this. But the problem here is attacker can take this message and replay several times to do some password guessing whatsoever. So, but it replay, okay, attacker send ID, hash of ID, okay, several times. Server give the response challenge, okay, enter the username and password, okay, but attacker they send this message again. It's a replay attack. So this kind of messages still have replay attack. So how to remove replay attack? No more modification attack, no more impersonation, but another is replay attack. To replay attack, we have to go for timestamp. Okay, like this one. We add timestamp, we hash timestamp. Okay, nobody can change here. Okay, it's all PKI. So this can occur at event 1. So we know that the TDMA is 5-second example. This message must reach here. This is 1. So this must be as 5. Okay, if at any point this message reach at 10 or 6, which means it's not fresh. So server will silently discard the message. So this is how we can deal with the replay attack. We introduce timestamp. Okay, so this resolves the matter. Okay, so how unilateral? So we send this ID, timestamp, hash of this. Okay, so this one is same message, no more impersonation attack. This one is reduced impersonation. This one is a replay attack. Okay, this one is modification attack, and this one is our confidentiality. Okay, so you see, so this one is the message is secure. But the problem with the whole is phishing, as we have done that before. So this one is authentication request message. So this server will send the challenge message. Okay, server will send all those server. This server timestamp. Okay, so timestamp of Alice, timestamp of Bob. Okay, so we ID of Alice, ID of Bob, and so we send all together hash of this one all. This all thing, we have to hash inside. So if any modification occur at anything, we know that. This one is to avoid impersonation. This one is challenge for mutual authentication. He addressed the challenge with this sign is address the challenge and this authorize. It seems okay, but server authenticate Alice, but Alice don't know it's authenticate, it's a Bob is a legitimate or not. So this is an example of unilateral authentication. We will go for mutual authentication. Okay, this one is security analysis. I have done that. Okay. So for this mutual authentication, the same thing, challenge. Okay. So at this point, okay, Alice sends a message and Alice sent the challenge as well. Okay. Bob sent the challenge. Okay, this one is challenge response. Okay, just like secure word. Okay, and then Bob sent the challenge. Okay, Alice resolved the challenge, and Alice resolved this this challenge is the same thing. Another challenge for this message. Each message must have the challenge, otherwise problem. Okay, so once all this done, we share the AK authorization key. Later on, no need to this whole procedure. Just use this AK and encrypt the message. Okay, so this one is mutual authentication. Okay, still for password guessing is still there. We have learned that. This one is example of multi-factor, dual factor. Okay, so we go for OTP. Okay, here the same thing, the same message is the same. See, Alice timestamp is Bob ID, Bob timestamp, hash for all those things, challenge and challenge this one, address AK, okay, request. Then we go for OTP. This is two-factor authentication. These are the examples how it looked like once we are in a real world. Okay, and then we have after OTP, okay, high-level authentication protocol, mostly online banking system using two-factor authentication. Okay, still sometime nowadays, I think 2 months ago, OTP is, I think in Malaysia, OTP is easy to get some, if we click the link and then there's some app, they can assist the attacker to get the OTP, bypass your mobile device. Or sometimes the device is stolen. Okay, so we'll go for biometric. Okay, this one is biometric. The same messages. If you read this, all is the same. It's a biometric hash means is proven. Okay, so no more lightweight, high authentication overhead, and high computation cost. We get this secure system at the expense of all those things. Okay, 10 times if you this is high level of computation. Okay, around 60 computations. If we calculate here, this one is one hash, one computation. Okay, this another computation, another computation. Okay, this another computation. So there are 60 computations around it. It doesn't have lightweight. So, but at the end of the day, we need a lightweight. So this is trade-off. You see, if it's a lightweight, there's a problem. Okay, and if it's a not lightweight, we have high computational cost. Okay, it's a trade-off. Okay, so you see this one is, if you see this is a lightweight mutual authentication. Okay, this they're using biometric. Okay, so timestamp. Okay, so it's easy to understand. So which means this example only that it looked like lightweight, but still we have high computation here. So many computation. Okay, so this is how our authentication happen in our real life. So in this lecture, nutshell, in this lecture, we begin with our cryptography. Okay, the first lecture is more on impersonation. What are the security requirements? We know that CIA and non-repudiation, and then we know our challenges. Those are interruption, interception, modification, and fabrication. The first lecture. And then we talk about the control or mitigation methods. We have the vulnerabilities, weaknesses. Okay, so the control is go for encryption. Okay, so in our second lecture, we talk about cryptography, symmetric, asymmetric key. Okay, and then we discuss what the problem with symmetric, and then we learn some baseline algorithms. Okay, and then for symmetric, we learn what are the issues, and then we go for asymmetric. That asymmetric is basically also known as public key crypto system. Okay, then we discuss what are public key. It look like secure, ensure confidentiality. Okay, but there is a problem with the impersonation attack. Then we go for PKI. PKI can assist for CIA and non-repudiation. Okay, and then we try to utilize those PKI okay, in our real-time authentication mechanism. Then we learn what is authentication, authorization, identification. Okay, and then we apply those crypto system in our union letter authentication, multi-factor authentication, then unit authentication, mutual authentication, two-factor authentication, and multi-factor authentication. This one is we learn that this is basically each messages are using PKI. You see, this one is hashing modification. This one is confidentiality. Okay, this one is using private key. Okay, so this one is impersonation, modification, confidentiality, and then we assume that availability is the unless until somebody cut the link. Okay, and then we reduce the replay attack here. We use timestamp, and then we use challenges to ensure it's a mutual authentication. Okay, and then later on, besides challenges, we introduce OTP go for two-factor authentication, and besides challenges, OTP, we go for biometric to ensure multi-factor authentication. We learned that multi-factor authentication is one of the secure mechanism, but it comes at high cost. I think that's all for today. Okay, so if we have any question, we can discuss in WhatsApp group. Okay, take care. Bye-bye.
Okay, for any question and answers, maybe we can use WhatsApp group. Okay, for manual attendance, you just write down your course code and your metric number. So later I will do that attendance maybe this evening. I have to rush.